Welcome to qnawire.
In this problem, the first part is to draw the free body diagram for the joints between the two cables in the middle cable. And so we have a tension force, I'm going to call it T1, directed up here. The angle between T1 and the horizontal is 60 degrees. This isn't the angle the problem gives us. The angle the problem gives us is this angle here. But by alternate interior angle theorem from geometry, these two angles are equivalent. We also have a tension force T2 going this way, and it's at an angle 40 degrees. Now, I didn't draw this too well, but T1 is supposed to be more vertical than T2. We also have a weight force going downwards. And so this is the full force diagram for this situation. Since T1 is more vertical than T2, it must support more weight. And so T1 is greater than T2. And that's the end of part A. In part B, we want to figure out that if these wires can hold a tension of 5,000 newtons, what is the maximum the weight could be? Since T1 is larger than T2, we're going to set T1 to be 5,000 newtons, and then T2 will be some value less than that. So now I'm going to apply Newton's second law in the x direction. It's equal to 0 since there's no acceleration in the x. This implies that T2 cosine 40 minus T1 cosine 60 is equal to 0. By the way, I'm letting my coordinate system be positive x here and positive y that way. Now, since we know T1 is 5,000, we can easily solve this for T2. And when we do so, we get 3,264 newtons. And so it is indeed somewhat less than T1. That's not the final answer, though. We have to still apply Newton's second law in the y direction. Sum of the forces in the y direction is equal to 0, no acceleration in the y. This implies that T1 sine 60 plus T2 sine 40 minus the weight is equal to 0. And now we can solve this for the weight since we now know T1 and T2. When we do that, we get 6,400 newtons, and that's the final answer.